When dealing with electrical metallic tubing, or EMT conduit, installations exceeding 2 inches in diameter and requiring a rain-tight connection, several approaches can be considered to meet both local and national electrical code requirements. Since rain-tight fittings for EMT conduit above 2 inches may not be readily available or may lack underwriters' laboratories, or all listing at a given time, alternative methods must be employed. Firstly, one viable solution involves the utilization of ceiling fittings. These fittings are designed to create a barrier against moisture ingress and are available in various sizes to accommodate different conduit diameters. When selecting a ceiling fitting, it is crucial to ensure that it is appropriately sized for the EMT conduit being used and that it is installed correctly to provide a reliable seal. The installation process typically involves cleaning the conduit ends, applying a sealant or thread compound to the fitting threads, and tightening the fitting to the manufacturer's specified torque. This creates a compression seal that prevents water from entering the conduit system. Secondly, another approach is to employ a rain-tight enclosure. Rain-tight enclosures are specifically designed to protect electrical components from exposure to the elements, including rain, snow, and ice. These enclosures are typically constructed from durable materials such as metal or fiberglass and feature gaskets or seals to prevent water from entering. When using a rain-tight enclosure, it is essential to ensure that all electrical connections within the enclosure are properly insulated and protected from moisture. This may involve using waterproof connectors, sealing compound, or other protective measures. Additionally, the enclosure should be mounted securely and in a location that minimizes exposure to direct rainfall or other sources of moisture. In situations where the available options do not fully meet the requirements for a rain-tight connection, it may be necessary to consider alternative conduit systems altogether. For example, rigid metal conduit, or RMC, and intermediate metal conduit, or IMC, are both approved for use in wet locations and offer greater protection against moisture ingress than EMT conduit. These conduit systems typically have threaded connections that provide a secure and water-resistant seal. When selecting a conduit system, it is essential to consider the specific environmental conditions and the requirements of the electrical code. In the areas with severe weather or high levels of moisture, it may be necessary to use a more robust conduit system to ensure the safety and reliability of the electrical installation. When working with electrical systems, it is always important to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. An electrician can assess the specific requirements of the project and recommend the most appropriate solutions for creating a rain-tight connection with EMT conduit or other conduit systems. Moreover, it's important to review relevant sections of the National Electrical Code, or NEC, which provides specific guidelines for electrical installations in wet locations. For instance, NEC Section 300.6 addresses protection against corrosion and requires that all metal components used in wet locations be made of corrosion-resistant materials or be protected by a corrosion-resistant coating. This includes conduit fittings and enclosures. NEC Section 314.15 covers the requirements for boxes, conduit bodies, and fittings in damp or wet locations. It specifies that these components must be designed and installed to prevent water from entering or accumulating inside. This may involve using watertight connectors, sealing compound, or other protective measures. NEC Article 358 pertains specifically to electrical metallic tubing, or EMT, and provides guidelines for its installation and use. While EMT is not inherently rain-tight, it can be made suitable for wet locations by using appropriate fittings and installation techniques. NEC Section 358.42 addresses couplings and connectors and requires that they be made tight. However, it does not specifically require them to be rain-tight. Therefore, additional measures may be necessary to ensure a rain-tight connection in wet locations. NEC Section 225.22 covers raceways on exterior surfaces of buildings or other structures. It requires that raceways be arranged to drain and be suitable for use in wet locations. This means that the raceway system must be designed to prevent water from accumulating inside and must be constructed of materials that are resistant to corrosion. In addition to the NEC, local electrical codes may also have specific requirements for electrical installations in wet locations. It is essential to check with the local authority having jurisdiction, or OJ, to ensure that the installation meets all applicable codes and standards. When selecting fittings and enclosures for use in wet locations, it is important to choose products that are specifically listed for this purpose. UL-listed products have been tested and certified to meet specific safety standards and are more likely to provide reliable protection against moisture ingress. Look for products that are marked with the UL symbol and the words wet location or rain tight. The selection of appropriate fittings, enclosures, and installation techniques depends on several factors, including the severity of the weather conditions, the type of electrical equipment being protected, and the requirements of the electrical code. In some cases, it may be necessary to use multiple layers of protection to ensure a rain-tight connection. For example, a ceiling fitting could be used in conjunction with the rain-tight enclosure to provide added protection against moisture ingress. Regular inspection and maintenance of electrical systems in wet locations is essential to ensure their continued safety and reliability. Over time, fittings and enclosures can deteriorate due to exposure to the elements, which can compromise their ability to protect against moisture ingress. It is important to inspect these components regularly for signs of damage or wear and to replace them as needed. Additionally, any sealant or thread compound used to create a rain-tight connection should be reapplied periodically to maintain its effectiveness. Proper grounding is also essential for electrical systems in wet locations. Grounding helps to protect against electrical shock and reduces the risk of fire. All metal components of the electrical system, including conduit, fittings, and enclosures, should be properly grounded in accordance with the NEC. In addition to the technical aspects of creating a rain-tight connection, it is also important to consider the aesthetic appearance of the installation. In some cases, exposed conduit and fittings can be unsightly and may detract from the overall appearance of the building or structure. To minimize the visual impact of the electrical installation, it may be possible to conceal the conduit and fittings behind walls or other architectural features. Alternatively, painted or coated conduit and fittings can be used to blend in with the surrounding environment. Furthermore, when considering different wiring methods, always keep in mind the specific application and environment. For example, direct burial cable, or underground feeder, or off cable, might be appropriate in some outdoor situations, offering a more direct and protected pathway compared to conduit systems. However, local codes and soil conditions must be carefully evaluated before choosing this option. Ensuring proper depth of burial, protection from physical damage, and compatibility with the surrounding environment are critical for the long-term performance and safety of direct burial cable. Proper selection and installation of connectors and terminations designed for direct burial applications are also essential to prevent moisture ingress and corrosion. If using a raceway system for running conductors along the exterior of a building, expansion fittings should be installed in long runs to accommodate thermal expansion and contraction of the conduit. These fittings allow the conduit to move without putting stress on the connections or the building structure. Expansion fittings are particularly important in areas with large temperature fluctuations, as the expansion and contraction of the conduit can be significant. The NEC specifies the requirements for expansion fittings in section 300.7 and provides guidelines for their installation and spacing. When using ceiling fittings or other types of watertight connectors, it is important to follow the manufacturer's instructions carefully. These instructions will provide guidance on the proper installation techniques and the recommended torque values for tightening the connectors. Over-tightening or under-tightening the connectors can compromise their ability to create a watertight seal. In addition to ceiling fittings and rain-tight enclosures, there are other specialized products available that can be used to create a rain-tight connection with EMT Conduit. These include heat shrink tubing, waterproof tape, and sealant compounds. Heat shrink tubing can be used to seal the connection between the conduit and the fitting, while waterproof tape and sealant compounds can be used to fill any gaps or cracks in the connection. When using these products, it is important to choose products that are specifically designed for electrical applications and that are compatible with the materials being used. To ensure that the electrical installation is safe and compliant, it is recommended to have it inspected by a qualified electrical inspector. An electrical inspector can identify any potential hazards or code violations and can provide recommendations for correcting them. The electrical inspection process typically involves a visual inspection of the electrical system, as well as testing of various components to ensure that they are functioning properly. If any deficiencies are found, the inspector will issue a report outlining the necessary repairs or corrections. Addressing these deficiencies promptly is essential to ensure the safety and reliability of the electrical installation. Remember that electrical work can be dangerous and should only be performed by qualified individuals who are trained in electrical safety procedures. Always to energize the circuit before working on any electrical components and follow all applicable safety precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Furthermore, ensure that all electrical components used in the installation are properly labeled and identified. This will make it easier to troubleshoot any problems in the future and will help to prevent accidental contact with energized parts. Labeling should include the voltage, amperage, and circuit number for each component. Permanent markers or labels should be used to ensure that the markings are durable and legible. The use of proper tools is also critical for ensuring a safe and reliable electrical installation. Use insulated tools that are specifically designed for electrical work and that are rated for the voltage being used. Avoid using tools that are damaged or worn, as they can increase the risk of electrical shock or injury. Before beginning any electrical work, it is important to thoroughly plan the installation. This includes determining the location of all electrical components, the routing of the conduit, and the size and type of wire to be used. A detailed plan will help to ensure that the installation is efficient and compliant with the electrical code. It is also important to obtain any necessary permits before beginning any electrical work. Permits are required for most electrical installations and help to ensure that the work is performed safely and in accordance with the electrical code. Contact the local authority having jurisdiction or urge to determine the permit requirements in your area. Also remember that the NEC is updated every 3 years, so it is important to stay up to date on the latest changes. The NEC is a comprehensive set of standards for electrical installations and covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Staying current with the NEC will help to ensure that electrical installations are safe, reliable, and compliant. Moreover, consider attending electrical training courses or seminars to enhance your knowledge and skills. These courses can provide valuable information on electrical safety, code compliance, and best practices for electrical installations. Many organizations offer electrical training courses, including trade schools, community colleges, and professional associations. Continuous learning is essential for staying current with the latest technologies and techniques in the electrical industry. When selecting an electrician or electrical contractor, it is important to choose a qualified and experienced professional. Check their credentials, licenses, and insurance to ensure that they are qualified to perform the work. Ask for references and check online reviews to get an idea of their reputation and quality of work. A qualified electrician will have the knowledge and skills necessary to perform the electrical installation safely and in accordance with the electrical code. They will also be able to provide valuable advice on the best solutions for creating a rain-tight connection with EMT Conduit or other conduit systems. Finally, maintaining detailed records of the electrical installation can be helpful for future maintenance and troubleshooting. These records should include a wiring diagram, a list of all electrical components, and a record of any inspections or repairs that have been performed. Keeping these records in a safe and accessible location will make it easier to locate and correct any problems that may arise in the future. These are just some of the considerations for creating a rain-tight connection with EMT conduit above 2 inches. By carefully considering the specific requirements of the project and following all applicable codes and standards, it is possible to achieve a safe and reliable electrical installation.